Okay, Year 10, we're going to move on to the next exercise, which is learning to find distance midpoint gradient on the next lesson. There are three formulas for these. I'm going to explain what they are and where they come from. And then you have to practice and do lots of practice and then apply them to different HSC type questions. So let's have a look. Now, we've already done finding the equation line. That was in the last lesson. But you will have noticed we skipped a couple of questions from exercise 5F. We will come back to these. But there are two equations here or two formulas here that I haven't shown you. This one here, which is a point gradient form, we're going to do that a bit later. And this one here, which is a gradient formula. Now it looks a little bit complicated. It's got y2s and y1s and x2s and x1s, but don't worry, I'm going to show you where it all comes from. And we're going to do some questions with it. Once you see where it comes from, it actually is pretty easy. So now, the other two formulas. Now, the other two formulas are the distance and the midpoint. And here they are here. Here's the distance formula and the midpoint formula. And we're going to go through and do a whole lot of questions for this. We're only going to do question 4. I'm going to show you where these formulas come from. And again, there's x2s and there's x1s and y2s and y1s, but don't let it freak you out. You watch when you see it, it's pretty easy. So I'm going to use question 1 to explain this. So let's have a go at it. So here I have a diagram, and I have a set of two coordinates, or set of 2 points. And this one here is the coordinate 1 and 2. The 1 is the x value, and the y value is 2. Up here, this coordinate is 5 in the x and 7 in the y. Now, I'm going to show you how we get these things. So over here, they say, find the horizontal distance, find the vertical distance, and use Pythagoras to find, and we're going to do that. But first of all, so here we go. Come on. Right. So we already know how to find this distance. It's from the y value 2 to 7. So to go how far between 2 and 7, you can just subtract them. 7 minus 2, and that will give you 5. And here, for this distance, well, I'm just going to subtract the x values. 5 minus 1, and that gives me 4. Now, once I know these distances, I can find the gradient and I can find the distance quite easily. I already know it's positive, so the gradient is m, the rise, 5 over 4. Now, if I didn't want to go through all the hassle of drawing a diagram, I think I could write a formula for that, and that's what we're going to do. We're going to call this point x1, I'll draw it below. We're going to call this coordinate x1, y1, so the first point. And we're going to call this coordinate x2, y2. Now, what do we do to find the gradient? Well, to find the gradient, we took the y values, y2 minus y1, and we took the x values, x2 minus x1. Now, here's a very important point. If we subtracted them in the other order, we'd still get the same answer. So let's do both of those. So what was y2? Well, that was 7. What was y1? That was 2. What was x2? 5. What was x1? 1. So 7 minus 2, 5 on 4. I don't even need to draw it. What if you did the subtraction the other way around? As long as you kept the order, the same points. So 2 minus 7, so I'm doing y1 minus y2. Doesn't matter which one I call it. and I'm doing 1 minus 5. So I'll get negative 5 on negative 4, and the negatives cancel each other out. So it doesn't matter which way I do it, as long as I keep the order. So there is your first formula, and you can see why it works. That's the gradient formula. Somewhere in your notes, you need to write that down. Now let's go back to this triangle. Essentially, I want to find the distance from here to here. Well, how can I find that? Well, I'm very lucky. I've got a right-angled triangle. And using Pythagoras' theorem, that's just going to equal the square root of this squared, 5 squared, and this squared, 4 squared. So the distance will equal the square root of 5 squared plus 4 squared, which is the square root of 25, plus 16, which equals the square root of 41. But let's now do it using the formula. Imagine I hadn't drawn it. Well, how did I find? So the distance equals the square root, I don't know, of the vertical distance. It doesn't matter which order. So I'd like to keep my x's first. So we'll do the x, the horizontal distance. So x2 minus x1, that's a horizontal distance, squared, plus the vertical distance, y2 minus y1, squared. Well, 5 minus 1 squared plus 7 minus 2 squared equals 4 squared plus 5 squared, which is square root of 41. So there is your second formula. It's called the distance formula between 2 points. So we've got the gradient and the distance. Now the only other thing that remains for me to find is the midpoint. So somewhere along this line is a midpoint. Let's go, it's somewhere about there. It's the middle of this vertical line, and it's the middle of that horizontal line, the blue line and the green line. Well, how can I find the middle of 7? Right, let's have a look at the vertical. 7, well actually no, we should do the horizontal first. Between 1 and 5. How do I find the middle of 1 and 5? It's easy. Add them together and divide by 2. So this point will be 1 plus 5 over 2. That's the middle. 1 plus 5 is 6 over 2. That's 3. And as you can see, there it is, there's a 3. What about the middle of the vertical line? Well, we just do the same thing. 2 plus 7 over 2. That's 9 over 2. That's 4.5. Oh, gee. 4.5. And as you can see, there it is there. So, you don't need to draw it if you just can say, I'll just substitute those values, x1, x2, y1, y2, and I'll get a formula. So let's write it. The midpoint, we'll call it MP, is x1 plus x2 over 2 and y1 plus y2 over 2. Right, what were the x values? So the x values were 1 and 5. 1 plus 5 over 2. What were the y values? 2 and 9. 2 plus 7, sorry. I've already done the addition in my head. So that gives me 6 over 2 and 9 over 2, which is 3 and 4.5. And there is your midpoint formula. Let's tidy up that too, because it's a bit poor. Now, you need to copy them and write them down. So here is gradient, the gradient formula, and you're only applying the three of these. Here is the distance between any 2 points, and here is the midpoint, and you need to put those notes or write those notes up. Okay, so what are we going to do now? We're just going to go to question 4 and we're going to apply this. Now, you won't have all the answers in the back of the book because in question 4, they just say find the distance, but I want you to find the distance, the midpoint, and the gradient. And I want you to do it for the first 2 columns. Now, there's a method that I want you to do. So here we go. I'll do the first column, you can do the second column. Or you can do them both. If you think you can do them, off you go. Come back and have a look. So here's 4A. Now, my first thing that I think you should do is write the coordinates above each other. So what have we got? 0 and 4 and 2 and 9. Now, there's a reason why I want you to do that, because it means that your x's line up and your y's line up above each other. And because we're going to do subtraction, right, making sure we keep the order is important. So here we go. Let's just do the gradient first. M. Well, I subtract the y values, 4 minus 9. Remember, it doesn't matter which one, all right, it doesn't matter which one you call x1, y1, as long as you keep the order. So it's the top point, the top coordinate, minus the one underneath, the second coordinate, the bottom coordinate. So 4 minus 9, and then I subtract the x values, 0 minus 2. 4 minus 9, negative 5. 0 minus 2, negative 2. 5 over 2. And I like to keep it as an improper fraction, but you might like to write 2.5. Okay. The second part, the distance. And again, I've already done the subtraction. That's why doing these three together is so much easier. I'm going to do the x ones first. I get 0 minus 2 squared plus 4 minus 9 squared. So that's going to be the square root of negative 2 squared plus negative 5 squared. Now here's the interesting thing. The negatives are just going to go because you're multiplying a negative by a negative. So it's just going to be 2 squared, 4, plus 5 squared, 25, and we'll leave that as a third, root 29. Okay, the midpoint. The midpoint. And this is what I want you to do for all of them. Just add the x's, 0 plus 2 over 2, and add the y's, 4 plus 9 over 2. Well, 0 plus 2 is 2 over 2. 4 plus 9 is 13 over 2. 2 divided by 2 is 1. 13 divided by 2 is 6.5. And there you have it. You have the gradient, you have the distance, and you have the midpoint. Now remember, the only ones in the back of the book you're going to have the answers for are the distance, but I still want you to go through. So you go away and have a go at them. I'm going to do D and G. You come back when you're finished and check your answers. So D, and again, write your coordinates. Now, because I'm used to this, I'm going to write that one above and that one below, just because I know the subtraction is going to be easier. Doesn't matter though, so I've got 1, 1, and negative 3 and 8. Double check, make sure they're the right points. 1, 1, negative 3, 8. So let's find the gradient first. M. Remember, subtract the y values. So 1 minus 8, and subtract the x values. 1 minus negative 3. 1 minus 8 is negative 7. And 1 minus negative 3 becomes 1 plus 3, 4. So the gradient is negative 7 over 4 or negative 1 3/4. Now remember, there's no answer in the back of the book for that. The distance, the distance equals the square root. Subtract the x values. 1 minus negative 3 squared plus 1 minus 8 squared. So that'll give me 4 squared plus negative 7 squared, which is the square root of 16 plus 49. 16 plus 49, 6 plus 49, 55, 65, root 65. Oh, if only been root 66, because that's where I get my kicks. All right, now the midpoint. And this is the easiest part. Add the x values, 1 plus negative 3 over 2 and 1 plus 8 over 2. What do I get? Negative 2 over 2 and 9 over 2, which gives me negative 1 and 4.5. Now, if you really wanted to be particularly good about this, you'd graph these 2 points and make sure they're all right. So we have 1, 1. Well, 1, 1's about there, and 3 and negative 8 somewhere down there. Well, it's probably too far across. 1, 2, 3, 3 and negative 8. 1, 2, 3, 4, 5, 6, 7, 8, way down here. And there you go. Now, yes, it's a negative gradient. Have I done that right? 1, 1. Oh, I've drawn that the wrong way. Thank goodness. Righto. I went down instead of going up. So we'll draw that again. There's 1, 1. And what's the other point? Negative 3 and 8. 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7, 8. Somewhere around there. I'm not that fast. So it's a negative gradient. Whew. The y-intercept's going to be in there, but we don't need to worry about that. But the midpoint, negative 1 and 4, well, that makes about sense, isn't it? Negative 1 and 4.5. So it looks right if I'd drawn it right the first time. Now, I'm going to do the last one. You go away and have another go. Well, not the last one in the first column. You've got to do the second column, remember. Negative 8, negative 1, 2 and 0. G. 2 and 0. It doesn't matter which way you write them. Negative 8 and negative 1. Let's double check, make sure we got the right ones. Negative 8, negative 1, 2 and 0. Okay, the gradient. Well, the gradient, subtract the y values. 0, so remember, x and y. 0 minus minus 1 and 2 minus minus 8. 0 minus 1, 1. 2 minus minus 8 is 10. So this is a very flat line. It's 0.1, the gradient. So it's not very steep at all. It's positive. It's like that. Probably even flatter. It's probably like that. Okay. The next point. The next thing. Distance. Distance equals the square root. We'll subtract the x values. 0 minus minus 1 squared. And the y values. 2 minus negative. Done them around the wrong way. I want to do the x values first. 2 minus minus 8 plus 0 minus minus 1. Well, that's going to be the square root of 10, got a square, 10 squared plus 1 squared, which equals 101. Now, the next one. The next one, the midpoint. Again, I'm just adding the x values. So what were the x values? 2 and negative 8. So 2 plus negative 8 over 2. And adding the y values. 0 plus 1. Double check. Negative 1. So what do I get? 2 plus negative 8, negative 6 over 2, and negative 1 over 2. So I get negative 3 and negative a half. So I'm just going to plot these 2 points to make sure that I've got them. But you should be right. I already know the 101's right because I've checked the answers in the back of the book. So where are these 2 points? The first one, negative 8 and negative 1. And I'm only doing this to get an idea. So negative 8 and negative 1, somewhere around there. And 2 and 0 is somewhere around there. So, yeah, the gradient looks right. Oh, geez, even that's pretty bad. But the main thing I want to check is this negative 3.5 and negative a half. So 1, 2, 1, 2, 3, 3. Yeah, that looks about right. So I know that I'm in the right ballpark. Anyway, that's distance, midpoint, and gradient. Make sure you write some notes and write down the 3 formulas. Make sure you practice. You know what? I'd probably do the last column as well, just to make sure you're doing it okay.